equals horizontal component is 15.3 and this time is 4.46. Yes, 16. 68.32. Right. One more there, right? Velocity again. Right. So then we know again when it comes to this point, the horizontal velocity remains constant, right? So that is still 15.3. So you have to find this velocity vertical component, right? Again you can do it again twice, either from compare from there to there or there to there, right? That time you can do either way. Now we know the displacement, we know. If we consider from there to there, from top to the bottom, right? Or you can again, just like this method, you can calculate for the total motion. I show the equations for both. Right. Let's consider from top to bottom only. Right. So from here to here. Right. So we can apply the equation downwards now. It's downward motion. So we know the displacement. What is that distance? 48 something. Total height. 4. So initial velocity is 0, starting from the highest point, the vertical 0. Acceleration is 9.81. We know we have to find the final velocity. So equation is 2as, right? So u0, so then it is 2 times 9.81 times 48.4. So this one's square root is v. What is v? .7, right? Or else you can consider the total motion like this, right? So this is simple, right? Do whatever the easiest way, right? If you consider total motion from there to there, right? So what are the information we know? So if you apply the equation upwards, because it's originally going upwards, we know the initial velocity, we know the final velocity, we know the acceleration, and also we know the displacement, and also we know the time, right? So any equation you can use. So then v squared equals u squared plus 2as. So now the problem is here the velocity is coming downwards as a minus value, right? So when we do the calculation, it could be a problem, right? So therefore it's better if you use this method, right? Or you can say the velocity is minus. So then minus v squared is, right? Again, but here again the problem comes. Or maybe not, we'll see. We just keep the velocity as it is, we'll see what's coming. Uh, 12.9 squared plus 2 into minus 9.81 times 40. What is this value? Is it minus or something? 400. It's coming as minus value, right? Oh wait, displacement was minus. Yeah, then it's okay. Right? So we apply the equation upwards, right? So initial velocity is upward 12.5, it's positive. Velocity is the one we are going to find. So if we apply the equation upwards, this is minus 9.81. The displacement is downwards, so then this one also become minus, right? So then v is root of this entire thing. So what is the value? So it also comes as 30 point something, right? So it's decimal points may be varying, right? Because of the sometimes we ignore the some numbers, right? So still the same answer, right? But this is not the final answer. We just calculate the vertical component, right? So using the vertical components and horizontal components, horizontal one is 15.3. Again, you have to calculate the resultant velocity, right? So resultant velocity if we take as v1 or something, right? v1 square equals 15.3 square plus 30.8 square, right? So then you can find v1 from this, and also you have given angle, right? If you take this one as the theta, right? So then it is theta equals tan inverse. So now this means 30.8 by 15.3. Check those questions in the PDF. The motion questions. There are two PDFs, so the one has motion questions. Okay. Now the first question there, right? So it's just like the one we did before, right? So it's thrown from a cliff horizontally, right? So we can use the same method. So we are not going to do it now, right? We do another one, right? So it's the same thing. You have to find the horizontal distance. Okay, this actually past paper questions from previous exams. Now the second one, so it is similar to the first question, right? Now when you are doing the calculations in the class, it may be given as an object or something, but in the questions it is given like this, right? Cricketer hits a bird with a ball, or someone shoots with a gun and then check whether the bird is dying or something like that. So the story is there, right? So but we have to do it with the normal calculation methods, right? So the second one is just like the one we did in the first question, right? So we have to find the horizontal distance, right? Third one actually not related to the projector. It is from the previous part, the one we discussed as the motion under gravity, right? So just the vertical motion is the object is falling from the rest. So you can just apply the equation, right? So try that one. If you want, we can discuss it next time. We will do the fourth one now. Boy was throwing a ball towards the ball. The ball was 5 meters from the boy. The top of the ball is 3 meters above the point where the boy released the ball. The boy tried to throw the ball over the ball, but sometimes the ball hits the wall. In one attempt, the boy threw the ball with an initial velocity of 9.7 at an angle to the horizontal of 49. Show that the ball traveled a distance to the wall in about 0.8. Try that one. It's easy. First part. Right, what are the two components first? Which one? This one? What is that? 6.3. Okay, this one? This is 9.7 cos 49, other one is sin 49. 3. Right. They are asking it takes about 0.8 seconds to reach the wall, right? Now you can do it several ways, right? Depends on the information you have, right? The easiest way to do is, right? So we know the horizontal distance, we know the horizontal velocity. So if you consider horizontal motion, it's equals ut. The distance is 5, velocity is 6.3 times t. What is t? This is for the horizontal motion. From there to there. There to there means when it reaches the wall. What is the time? 3. 0.7, right another this is 1.9. So this is almost 0.8. They are saying it is above 0.8 means it has to be a cross value. Maybe sometimes it can be higher, it can be lower. And next one, deduce whether or not the ball went over the wall for this attempt. Right? Now, don't make this mistake. Now, it never says that this is the highest point of the motion. Right? So sometimes if you see, most of the students when we discussing this question, right? So they assume this is the highest point. They calculate it as the highest point, considering it like this. No, it's not. No, it's not the highest point. It can be anything, anywhere. The wall can be any point. Right? Now, best thing you can do is now you know the time taken for the object to reach from there to there. Right? Now you know the initial vertical component. You know the acceleration. Right? Now, if we can calculate the vertical height, right? So after 0.1, now we know the initial velocity vertically upwards, we know the time, we know the acceleration, and if we can calculate the vertical height, right? So if that height is above 3, so that means the ball is going something like this. So that means when it reaches 0.8, so that means it is in this level. So if the height is 3.5 to 4 5 like this, so that means it is going above the ball. So if the height is less than 3, if it is 2 point something, so that means it hits the ball. Clear? And so we calculate this. So then what is the equation? S equals ut plus half lt squared upwards. Right? 7.3 times time is 0.8 plus half into, now going upwards, minus 9.81 times 0.8 square. What do you get the height? Right, so it's coming as 2.7. Right? So that means at this point the height of the ball is only 2.7. Right? So that means it is not reaching the it does not go above the wall. Right? So now when they are asking in the question, deduce whether this one is going over the wall or no. Right? So that one you have to give an answer. For that one you will get a mark. Right? So you have to give a valid conclusion. So when you calculate this height, it's 3.7 meter, 2.7 meter. It's less than 3. Therefore, ball will not go over the wall. Right? You have to give it as a comment. So giving that comment, you will get 1 mark. Right? Now in the first for this question, there are 4 marks will be given. Right? Now those 4 marks are given like this. For using the correct vertical components, you will get 1. So that means finding this one. So it has not asked before. It not asked, the components are not asked. So therefore, using the correct components, 1 mark will be given. So then for using the correct values in the equation, you will get another mark. For the answer, 3rd mark, and the 4th mark will be given for conclusion. No, it won't go over the wall. That can be not right. Right? So in the previous step also there are 3 marks. Right? In that one also, finding this component you will get a mark. Applying the values correctly in the equation get a mark, and the final answer is 0.79 will get another mark. And that's how the marks will be normally given. Right, so you can try the remaining questions, right? Especially that next one is somewhat similar to this, right? You have to compare something, right? And the last question is little bit tough, right? So that one also try. So we'll discuss what are the problems you have, and also we'll be moving to the next part of this lesson next time. Okay? So the motion part is done, right? So you can go through, even if you download the papers, you can do any motion related questions now. Right?